Hello friends, today we are diving into one of the most fundamental topics in physics, motion and related concepts. This includes motion, speed, velocity, acceleration, momentum and more. By the end of this lecture, you will have a solid understanding of how objects move and interact with the forces in the real world. Let us begin with the basic idea of motion. An object is said to be in motion if its position changes with the time relative to an observer. This change could be as simple as walking across a room or as complex as the orbit of a satellite. Motion is everywhere, and understanding it helps us understand how the physical world works. Distance versus displacement. Now, what is the difference between distance and displacement? Distance is the actual path length covered by an object. It is a scalar quantity, meaning it only has magnitude. Displacement, on the other hand, is the shortest distance between the starting and final position with the direction, making it a vector quantity. For example, if I walk 100 meters in a zigzag path, that is the distance. But if I end up only 60 meters from where I started in a straight line, that is the displacement. Speed, velocity and acceleration. Let us talk about how fast things move. That is where speed, velocity and acceleration come in. Speed is the distance divided by time. It does not care about direction. Velocity is displacement divided by time, so it does involve direction. Acceleration is the rate at which velocity changes over time. If an object speeds up or slows down, it is accelerating. For example, a car going around a curve at a constant speed is still accelerating because its direction is changing. Equations of motion. We use equations of motion to solve problems involving moving objects with constant acceleration. Here are the three key equations. S is equal to ut plus half at square. V is equal to u plus at. V square is equal to u square plus 2as. These equations relate displacement, velocity, acceleration and time. We will use them often in problems involving freely falling objects or vehicles speeding up or slowing down. Deceleration or retardation. Now what happens when an object slows down? That is called deceleration or retardation. It is just a negative acceleration. So if you apply brakes in a car and your velocity decreases, your acceleration is in the opposite direction to your motion. Projectile motion. A projectile is any object that is thrown and then moves only under the influence of gravity. Think of a basketball shot or a cannonball. The path it follows is called the trajectory, and that path is a parabola. Interestingly, the range, the horizontal distance covered, is maximum when the object is launched at a 45-degree angle. Types of motion. Let us look at different types of motion. Translatory motion. The entire object moves in the same direction. Rectilinear motion. Straight line motion like a lift moving up and down. Curvilinear motion along a curved path like a rocket. Rotatory motion. Object rotates about a fixed axis like a fan. Oscillatory motion back and forth like a swing. Periodic motion repeats at regular intervals like Earth's orbit. Understanding the type of motion helps in analyzing the behavior of the system. Dimensions of motion. We can also classify motion based on dimensions. One-dimensional motion is along a line, like a train on a track. Two-dimensional occurs in a plane, like a boat on a lake or a projectile in the air. Three-dimensional motion happens in space, like a butterfly flying or gas molecules moving freely. Momentum. Next is momentum, one of the most important concepts in physics. It is defined as the product of mass and velocity, P is equal to mv. Momentum is a vector quantity. It depends on direction. It tells us how much motion an object has, and it plays a big role in collisions and explosions. Inertia. Inertia is the tendency of a body to resist changes in its state of motion. There are some great everyday examples. When a train starts, you feel pushed backward. That is inertia of rest. Athletes run before jumping to gain more inertia of motion. When you fire a gun, it recoils due to the conservation of momentum. That is inertia and Newton's laws at work. Newton's third law. This leads us to Newton's third law of motion. For every action, there is an equal and opposite reaction. That is why we can swim. Pushing water back propels us forward. Guns recoil after firing. Rockets lift off. Exhaust gases push downward and the rocket moves upward. These actions and reactions act on different bodies, so they never cancel out. To summarize, we explored motion and its type. We discussed speed, velocity, acceleration as well as their formulas. We looked at projectiles, momentum and inertia. Finally, we examined how Newton's third law explains many natural phenomena. Understanding these basics is the first step to mastering physics. Okay, thank you.